ever driven over a huge concrete bridge and just wondered, how do we know this thing is going to last for 50 or even 100 years? I mean, how can we be absolutely sure it won't start crumbling from the inside out? Well, the secret is in this incredibly clever and surprisingly fast test, one that can predict decades of durability in just 6 hours. Let's get into how it all works. Okay, so to really get the solution, we first have to meet the villain of our story. There's this hidden threat, right? An invisible enemy that can bring down our most massive structures. So what is it? What is slowly eating away at our infrastructure from within?
The enemy is microscopic, but believe me, its impact is enormous. It's a chemical reaction that kicks off the second certain common materials touch the surface of our roads and bridges. Say hello to the chloride ion. This little guy is the tiny corrosive part of the de-icing salts we use to keep roads safe in the winter. And, it's everywhere in seawater. By itself, it's just a particle. But when it gets near concrete, that's when it turns into a relentless invader. So here's how the attack really goes down. First, salty water hits the concrete. Then, those chloride ions start a very slow journey, seeping through a massive network of tiny invisible pores inside the concrete. And their target? It's the steel rebar, the stuff that gives concrete all its strength. Once the chlorides reach that steel, they kick off corrosion, basically rust. And as that rebar rusts, it expands with this incredible force, literally cracking our bridges apart from the inside out. So you can see why it's absolutely crucial to know how well a certain concrete mix can fight off this invasion. The problem was, for a very long time, testing for this was an incredibly slow process. The old school method, called chloride ponding, was exactly what it sounds like. You literally just let salt water sit on top of a slab of concrete for months, and then check to see how far the chlorides got. Sure, it works, but in the fast-paced world of modern construction, waiting 3 months for one test result? That's just not gonna fly. And the difference here is just staggering. Seriously, we're not talking about a small improvement. We're talking about going from a process that takes a quarter of a year to one you can get done in a single workday. This is a total game changer for building things on time, on budget, and even for trying out new ideas. So how on earth did they do it? How did they achieve this incredible speed up? Well, they didn't just tweak the old test. They came up with a completely new way of thinking about it. And it's all thanks to a brilliant idea, using electricity. So let's introduce the hero of our story, ASTM C1202. That's the official name for the standardized test. And what it does is use electrical current to get a super fast, really reliable idea of how well concrete can block those nasty little chloride ions. The science behind this is actually wonderfully simple. Chloride ions have a negative charge, so if you create an electrical field, you can force them to move. This test basically puts a slice of concrete in an electrical field and just pulls those ions through way, way faster than they ever move on their own. It's literally like hitting the fast forward button on a process that would normally take decades. And this is the aha moment. It all comes down to this. If the concrete is really dense with very few pores for ions to get through, then very little electrical current can pass through it. That means you've got good concrete. But if the concrete is porous, it's like an open highway for those ions, and a lot of current will flow. And that's a big red flag for pore resistance. Okay, so that's the principle, and it's brilliant. But what does this 6-hour experiment actually look like when they do it in a lab? The whole process is really carefully standardized, so the results are reliable every single time. It starts with cutting a thin 50mm slice from the concrete you want to test. Then, that sample gets fully saturated with water in a vacuum. This makes sure every last pore is filled. After that, it gets locked into a special test cell, and only then is the electricity applied for exactly 6 hours. And this right here is the machine that makes it all happen. It's so cool to see how the detailed engineering blueprint on the left translates into the actual real-world device on the right. It's a precision instrument designed to hold that concrete sample and the solutions perfectly in place. Here's a great shot of a sample all locked in and ready to go. You can see that concrete slice sandwiched right between the two halves of the cell. The wires are attached to apply the voltage. The whole setup is just designed to isolate the concrete and measure only the current that's passing right through it. And with this test, precision is absolutely everything. It requires a constant 60 volts for exactly 6 hours. On one side of the sample, the negative side,
you've got a sodium chloride solution. That's what provides the chloride ions we're testing. And on the other side, the positive side, there's a sodium hydroxide solution. That's there to complete the electrical circuit and keep things flowing.
Now we put our specimens in the desiccator to dry. Make sure that the valve is on the right position, so it's closed from here and open from those two ends. This is connected to the vacuum pumper, which is gonna create vacuum inside this desiccator. So after 3 hours of maintaining vacuum in the vacuum desiccator, we connect these with distilled water. This is a bucket of distilled water. And then open the valve and fill it with distilled water. And submerge the specimens with distilled water for 1 hour while maintaining the pressure, while maintaining the vacuum. After 1 hour of introducing distilled water to the vacuum desiccator, we'll turn off the pump now. We remove the pressure from the vacuum desiccator. We'll leave the specimens in this chamber for about 18 hours.
Okay, 6 hours are up. The test is over, and we've got our data. But how do you turn a bunch of electrical readings into a simple, clear verdict on the concrete's quality? The final result is measured in a unit called coulombs. Now, a coulomb is just a measure of the total electrical charge that passed through. But for this test, you can just think of it as a score. The more current that flows during those 6 hours, the higher the final coulomb number is going to be. And a high score means a lot of those nasty ions made it through.
All right, so let's say the test is done, and the equipment spits out a reading of over 4,000 coulombs. What does that number actually tell us? What's the story with the concrete we just tested?
Yeah, exactly. Is the score over 4,000 good news, or is it bad news? Well, this is where the standard gives us a super clear, easy-to-read chart that turns that number into a rating we can all understand. So, that score over 4,000? According to the official chart, that gets a rating of high penetrability. And that is not what you want to see. It means the concrete is pretty porous and really vulnerable. The goal here is always to get the lowest number you can. A score under 1,000 is very low. And if you get under 100, that's considered negligible. That's the gold standard. That's the kind of concrete we want for our most important structures. So why does this one test matter so much? Well, it's an absolutely critical tool for quality control on new construction projects, making sure the concrete getting poured is as tough as it needs to be. It lets scientists and engineers quickly test out new and innovative concrete mixes. And at the end of the day, it just helps us make better, smarter decisions so that the roads, bridges, and buildings we rely on are safer and last a whole lot longer. This 6-hour test is just a perfect example of how scientific creativity can solve a huge real-world problem. It really makes you wonder, right? If we can predict 50 years of durability for concrete in just 6 hours, what other materials and what other challenges are out there just waiting for their own clever test to come along and unlock their secrets?